Good afternoon, everyone. Before we begin, please confirm that you can hear me and see the slides clearly by just typing yes in the chat window.
Yes,
Also,
I
we
can
would
hear you,
like you
Ms.
to
Asha.
introduce yourself, your name, your designation, company, and the country you are based in to have an idea of our audience. It's a pleasure to see an international audience of people from all industries and backgrounds. Good to see you all. Great. I'm getting your confirmations. Thank you so much for confirming. I would like to thank you all for registering and taking time out on a Sunday to learn about achieving AI goals by using AIMS APMS software, which is VAIL-Plant. My name is Aisha Khalik, and I will be your introductory speaker for today. It is our pleasure to host this webinar for you. This is our 90th webinar in a series of technical webinars that we are conducting. As a practice, we are conducting one webinar every month. Please follow us on LinkedIn and YouTube to make sure that you are updated about our updates. Today, we have an experienced panel of speakers. I am with my colleague, Mr. Ijazul Karim Rao, who is Director, Principal Integrity and Safety Consultant. Madam Mubina Khatun, she is Director, Engineering Services. Mr. Arshad Ali, he is Head of AI and Software Development Department at Velosi. Moving forward during this webinar, we encourage you to keep asking questions to clear any doubts which you have. You would definitely like your engagement on this topic. You can type your queries in question and answer window and you will receive a reply there, or we will answer it live. We will try to answer as many questions as we can, but due to limited time and a lot of questions asked during every webinar, we have to be selective. We will also be issuing participation certificates to all those who have attended at least 80% of the webinar and have participated in the webinar through question and answer session. Since this is quite a unique and technical subject, we will touch only the key theoretical and practical aspects of achieving AI goal by using AIMS APMS software, which is VAIL-Plant. In this limited 2 hours, we request you to follow us and keep asking questions to help us make this session as engaging as possible. So safety moment, before we begin, like always, we will go through a brief safety moment. Although most of us are attending this webinar from the comfort of our homes, we should be aware of emergency exits. We should keep a safe distance and generally take care of ourselves and those who are around us. So now I will invite Mr. Jazul Karim Rao to discuss the topic of today. Thank you so much.
Assalamu alaikum and good day, everyone. I know it's different time zones in different parts of the world, and in Middle East, Abu Dhabi, where I am now conducting this webinar, is 2:15 p.m. afternoon. Weather is getting better now in Abu Dhabi after summer. So today's topic is what is AI and AI progression, and what I will be presenting with respect to AIMS, Asset Integrity Management System, and how artificial intelligence aspects can help to better manage asset integrity of industrial sector. That is the objective. I would like to clarify that I am basically chemical engineer with process engineering background, and I have some expertise in asset integrity and HSC and engineering services. And we got a team of software engineers, different discipline engineers, including process, corrosion, inspection, maintenance, and HSC. So, as a combination, what we try to achieve, like how we can make combination of AI aspects in software, and then how we can use the AI features to manage our asset in a better way. So, what is AI? As a definition, if we try to see, like artificial intelligence, mean intelligence but artificial. So, how we differentiate for a common man? We all we know that when a child is growing up in a nursery or KG level, we try to bring the pictures and try to tell first the boy or girl, the child, this is an apple, this is a boy, or this is a cat, or this is a dog. And first we tell him or her, and then afterwards we ask, what is this? The boy tells what he learned. So that is called intelligence, simple intelligence. But how a computer can do that? Because computer does not have a brain. So computer work as a result of machine learning. Say we tell one time, two time, three time a pattern or a picture which could be recognized as a like basic definition. Okay, this is what it is, and then machine learn it. And let's say one time there would be one example coming after Like if we show a picture of a strawberry, we ask machine, what is this? If machine tells or computer tells it's a mango, we say, no, 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 it's strawberry. Second time also it may make mistake, but third time machine may also answer it is a strawberry. So that's the normal process basically. So as a definition, it is the science and engineering of making intelligent machines, especially intelligent computer program. It is related to the similar task of using computers to understand human intelligence. But AI does not have to confine itself to a method that are biologically observable. So here, like one thing we should know, machines will never be able to work like a human being because a human being works, brain works in multidimensional direction. But machine would be confined to work on the specific target or specific tasks that could be given. But like we can improve machine learning and machines robotics or programs can do various aspects of for the human being under the command of human beings, but it will never be better than the God gifted brain. This we have to understand. But to replace certain actions, to do certain things in the confined spaces, difficult spaces, hazardous spaces, so we can use machines to work for us. Like nowadays, like drones, robotics, and various aspects are being done by the machines. Now, how it started with machine learning or the artificial intelligence is not new. Turing test is done by Mr. Alan Turing in 1950s, and the best result was acquired in 1973, where example-wise there was a machine and there was a human, and there was a curtain between the human and machine, and there was a person who was asking questions. The answers were given by machine and answers were given by the human. The person who asked the questions could not differentiate like whether the answers were given by the machine or the human. So that was the beauty of that test, and it means that machine can work like human. That was the first thinking process which started in 1950s. Same time, like when we say when computer system making started, that was started in 18th century, 19th century, there was a big machine, but like a computational calculations, equational calculations, or uh, use of machine like a PLC, programmable logic control in the oil and gas sector or industrial sector. There is a DCS is also there. The SCADA system is also there. There are various, like then we have the uh, tele, telephone when it was discovered. Then there is a use of like a TV system, then internet, and all this is a progression in the development of the basically machine learning, which nowadays the more focus is being given to the as an artificial intelligence. Now, what are the main elements of the like artificial intelligence? Like if I just share my own experience, my son who is studying in Khalifa University here in Abu Dhabi and he is studying computer science, he always debates with me like my concept of artificial intelligence is not as modern as the artificial intelligence he perceives. He feels that like the pattern recognition, the like when the artificial intelligence function available, the YouTube, like if I'm listening a recitation of a Quran, then the YouTube will give me another kind of the same kind of subsequent videos, or the machine can also see what my pattern of life is, and so and so. So he feels that is a more artificial intelligence, whereas we feel like all the actions what we are doing through computer somehow is a part of artificial intelligence, is a part of machine learning. For example, when I'm writing a email and I have a auto corrector for the spellings, so if I'm writing some wrong spelling, so the machine does compare that word with the pattern given already built in the database for the mining, and it will correct that the word is this. So it means, and some pattern wise it can correct, spelling wise it can correct. That's also part of artificial intelligence. Similarly, like we have one example, like if we show a machine, okay, this is the right pattern and this is the wrong pattern. So, as a comparison point of view, like a corrosion on the surface of a pressure vessel or surface of a pipe. If it is there, brown color, this. If we teach machine, then machine through like a drone camera or through normal camera or through CCTV can differentiate between good and bad or like whatever the defects we try to define. So in general, there are five elements of the artificial intelligence, like natural language processing, number two, expert system, number three, robotics, number three, intelligent agents, then computational intelligence, which is further machine learning as a part of the computational intelligence. And under machine learning, there are three major areas: knowledge discovery, pattern recognition, and data mining. So this is the one of these elements or combination of all of these elements can be called as artificial intelligence. If I try to explain one by one as a normal pattern, I will go next slide. But as objective of this like a webinar, what we are conducting today, the objective is not to teach you how to do artificial intelligence, but what is artificial intelligence and how artificial intelligence is emerging and what are the basic rules for the game and then how it is relevant to the AIM system. That is the objective of my discussion. So as a result of this discussion, we are trying to make an awareness and orientation to develop a relationship between AI and asset integrity management system or software. That is the objective which I'm trying to achieve. Now, natural language processing (NLP) is a branch of AI that allows machine to use and understand human language. Like we know that in nowadays in Google we can give a command. Similarly, there are translators as well from one language to another language. So that is function available. A user first of all speaking, then speech to voice assistant goes, then voice assistant recognize it with the database comparison, and then API of the computer then give you natural language processing and response to the user. So this is one example. This technology scan the data in the form of raw language such as handwriting, voice, and images into contextually relevant structures that can easily be integrated with other structured data for more efficient analysis and response. It is built into products such as automated language translators used in multilingual conferences, text to speech translation, speech to text translation, and knowledge extraction from the text. So, like we are aware of the language wise, this feature is all of us are aware. Language can be converted into command, and then language can be translated from one English to French, French to Spanish, Spanish to Arabic, and so on. So recent application of NLP in the oil and gas industry include, as an example, I'm just saying that interacting with machine to troubleshoot unexpected problem in a timely and accurate manner. Then extracting information from the detail of production, which can be used to improve operational efficiency. So various factors are being used in oil and gas sector as well. Second thing, expert system. For example, if we have if we say example this side expert system, there is a non-expert user, simple input, and then we got the user interface, then rules engine, then knowledge base, expert system, and then we get the knowledge from an expert. By comparison, the machine gives us the right advice. So expert system are machines or software applications that provide explanation and advice to user through a set of rules provided by an expert. The rules are programmed into software to reproduce the knowledge for non-experts to solve a range of actual problems. In the oil and gas industry, expert systems have been used from exploration through production, from research through operations, and from training through fault diagnostic. For example, pipe sticking advisor to provide guidance on why drill springs get stuck and how to free them. Guideline could be provided by the machine. Then personal finance advisors user enter their monthly income and expenses, and the system provide boosting advice and saving tips. Then configure wellhead assemblies for production wells. So there are various examples what we can have, and this is an expert system interest rate calculations and your various plans you can have through the Google search. But these things are built with the help of expert system which is available in the system. Now robotics, where we are mostly familiar with. Robotics are the basically intelligent robots are mechanical structures in various shapes that are programmed to perform specific tasks based on human instructions. They are working under human instruction depending on the environment of use, land, air, and sea. They are called drones and rovers. So now, whether it is in the production side, whether it is on the monitoring side, whether on the inspection side, starting from robots to in the nuclear sector, in the reactor area where the nuclear reactor is present, then the normal human being it is dangerous. They cannot go there. They would be affected by the radiation. So robots are sent there. So they play an important role. Nowadays, even wars are being fought by the robots or by rovers or by drones. There's also one of the use of the robotics, and simple functions at home can also be given or are given to the robots as well. Then intelligent agents. A multi-agent system consists of multiple decision-making agents which interact in a shared environment to achieve common or conflicting goals. These systems are capable of maintaining information about the environment and making a decision based on their perception about the state of the environment, the past experience, and their objectives. For example, agents such as individual traffic signals, connected cars, and surveillance cameras collaborate to manage traffic flow dynamically, reduce congestion, and optimize travel time. The example, if you can see this, self-driving car using signal from multiple sources, these things available, which is intelligent agents are being developed as a part of the artificial intelligence function. Now, the last part, which is machine learning, which is coming from the computational intelligence. The computational intelligence is the computational aspect of AI that focuses on utilizing and driving value from data. It uses knowledge, discovery, and data mining processes to develop machine learning workflows, learn from historical data, and predict future events. Like machine learning point of view, how it works as a child training point of view, as I gave example earlier also. For example, if there is a strawberry, if a machine is asked, what is this? A machine is replying you as a mango, then no, it's wrong. Feedback is given to machine and machine says noted. And next time, if machine would be looking at the same pattern or same picture, it will tell it is a strawberry. Machine learning has multiple approaches like knowledge discovery, pattern recognition, and data mining. So knowledge discovery, we see that like a spelling corrections, pattern corrections, and this is you have a lookup tables where you can compare various patterns or various words with the right words, and with the passage of the processes, a machine learns that what is the right word and what is the wrong word. Next, pattern recognition is the same, it's not a spelling, but it's a pattern. For example, if the example is should be a Gmail, but written as a Gmail. It is not a word with a meaning, but it's a word with pattern. So machine can also configure or recognize the right pattern with the various collaborations if it is built into the machine. Checking if an email address is in the correct format, detecting patterns in real time, sensor data to forecast equipment and malfunction before that. So data mining means if there are certain databases or reviews or the patterns are available, then machine would be able to give you certain recommendation like what is right for you. For example, on a visiting a website, we see tailored product suggestions that increase the chance of you making additional purchases, enhance your shopping experience while boosting sales for the retailer. This is also part of the machine learning and artificial intelligence. Now, the advantage point of view is as reducing human error. I sometimes agree or disagree because sometimes machine or laptop, sorry, computer program does have a bugs, or sometimes may also guide you with a different pattern or different database. But if we make a specific task, specific robotics action, then human error can be reduced. So first of all, it can help to reduce the human task. Secondly, repeated tasks, it can be automated, and then efficiency of the machine can be improved. Right? Yeah, it goes against human being job side factor. We will just take an example. For example, the people who are used to travel, they can see, for example, Middle East. Previously, there were many immigration officers who were sitting at their desks and they were receiving all the visitors coming in and out of the country. Now there are eye scanners and are the face scanners. So those immigration officers, so many not required. So it means it has reduced the number of human beings, job opportunities, but at the same time, it has increased the efficiency and maybe the ease for the travelers. So it got pro and cons. Efficiency is being added into the system. Secondly, smooth handling big data. This is like a good thing, like a CMS system or like a SAP, maintenance management system. There are thousands or hundreds of thousands of tags. Or if you go to the Ministry of Interior, for every individual, there is a data which is being recorded, being tracked. And so this easy to manage large data for whether equipments or human being or store activities. So it can help to basically manage it effectively. It can also further process this data through interpretation and transformation. For example, if wish to see like a bad actors or the issues, equipments which are having a more failure trend, or the equipment which are having a lesser failure trend, positive, negative, both things could be assessed. So since we have a data trend, we have analysis of the things, so it will help us a quick decision making. For example, if we know that the equipment or machines with MTB having mean time between failure is higher, so it means it's a bad actor, and then root cause analysis can be done, and the right decision can be made. Similarly, inspection point of view or the store, like consumption wise, if few assets or equipments or components which are consumed heavily, so it means demand is high, the root cause done, analysis done, and then we can have a quick orders for those. So a system are always available, thus helping in faster decision making. This is one of the AI benefit as well. Then perform risky and like a difficult task efficiently. For example, as I gave example earlier also, like nowadays, previously if aeroplane is coming, it can be hit by the enemy missile. So nowadays, drone is being sent. So it is human life can be saved. Like enemy cannot shoot down your aeroplane with the pilot in. So this is also one of the aspect of like when drone is going there, a rover is going under the sea. So it is one of the benefit of the advantage of the AI. Similarly, as I said, in a radioactive area where human being could be affected by the radioactivity of that particular nuclear power sector or a nuclear power reactor. So we can send a robot, and that robot can do that activity very efficiently. Similarly, high temperature areas as well, job could be done by the robotics. So in the difficult areas, the AI can be used in the form of robotics or drones or rovers. So like enable digital assistant, there is a AI-based chatbots, reduce the need for unnecessary customer service staff. Like if you go, you're using Google Map. So Google Map, the sound assistance is there, which guides you. Like you go straight, you take a right turn, you take a left turn. So all these actions are basically AI-enabled digital assistants are available. Then helps in improving processes and workflows. So AI helps companies to work more efficiently, enhance productivity, and increase revenues. Help in improving tedious processes and offer better workflow, which are error-free, relatively, we can say. Then assist in medical applications. So the AI features are being used in all parts of the world nowadays, and same is the case in the health sector. For example, AI is directly involved in healthcare application and treatments. Medical practitioners are able to predict health risks rapidly with AI. AI assist in complex treatment procedures and such as radio surgery. Then AI-based surgery stimulators and detects neurological disorder and stimulate brain functions. These pictures are available. AI is a full-time available. Human being is like at least 6 to 8 hours would be sleeping, but machine awake always. So AI-based systems are available 24 hours and 7 days a week and can be accessed whenever required at any given time. Unlike human, AI-based systems can be productive all the time. AI systems are programmed to work for longer hours and can handle repetitive and monotonous tasks easily. So this is like a benefits are there. You all are aware of those, and then it also helps like in YouTube or other factors as well. We see in the world now in our daily lives. If we see, if I try to summarize, because we are making it to like whatever we do, that is a part of AI. If we know that is a part of AI, and then we can easily make it as a part of our day-to-day practice. Like voice assistant, we know there is a Amazon Alexa, Google Assistant, and Apple's Siri, and we have VAIL-Plant. We have given the name our voice assistant as a Sarah. Then recommendation system, services like Netflix and uh, Spotify use AI algorithms to analyze your preference and suggest movies or music based on your previous choices. Chatbots, many website features chatbots that provide customer support by answering common questions or guiding users through the processes. Image recognition, like it is a very common. Applications are available in Google Photos. Use AI to recognize faces and objects in the images, making it easier to organize and search for your photo library. Then navigating apps are also there. The Google Maps are there. The Google Maps and Waze use AI to analyze traffic patterns and provide optimal routes based on real-time data. Then smart home devices are also there, like a thermostat, like Nest learn your heating and cooling preferences over time, adjusting settings automatically for comfort and energy efficiency. Then spam filters are also there. Email service use AI to detect and filter out spam messages, improving your inbox experience. There are a few common examples. Then this is like if we say contribution from Veloci to introduce you. The other features, what you are going through, most of you would be familiar. However, like where like what we have done little research. Okay, what are the AI regulations and industry standards? So there are various standards which European Union and American Standard Institute have made. So the first one, if I see ISO IEC 22989, year 2022, artificial intelligence concepts and terminology. Then 23053 is the framework for artificial intelligence system using machine learning. Then ISO IEC 23894, guidance on risk management of AI. Then there is a ISO IEC-TR 24028, which was issued in year 2020, artificial intelligence overview of trustworthiness in artificial intelligence. Then ISO IEC-TR 24030, which was issued in 2021. Then use cases, like there are various cases which were built as a part of earlier AI exercises. Then there is American National Standard Institute standards are also there, which one is first one 2096, which is guideline for developing trustworthy artificial intelligence system. So then NCCTA 2089, definition and characteristic of artificial intelligence. So the message what I'm trying to give you, so there are standards and guidelines for the developers, for the users, like which we can use as a reference. So if we go a little bit more detail to these standards, so this is one of the like little idea, artificial intelligence concept and technology. This is the first standard, 22989. So what is in the standard? If I may show you, AI concepts, machine learning concepts, example of machine learning algorithms, then autonomy, heteronomy and automation, then Internet of Things and cyber physical system, trustworthiness. So you will see the different aspects. So there's also AI other system, AI ecosystem, AI system functional overview and so on, then application of AI system. So it's a good guidance available. So if this scope of the standardize the terminology and concept for artificial intelligence, covers AI programs like symbolic reasoning, machine learning, and hybrid approaches, then addresses ethical and societal consideration of AI, clarifies AI relationship with other emerging technologies. So purpose and objective, establish a common AI vocabulary, then enhance communication and collaboration, guide AI development and implementation, address ethical consideration, support AI regulation. This is the first standard. The second one, the framework of artificial intelligence system using machine learning. This is ISO IEC 23053. Here, if we try to see same way, so this standard machine learning system, tasks, then it goes to machine learning approaches, machine learning pipeline. So here the machine learning pipeline is a general data acquisition, data preparation, modeling, verification and validation, model deployment and operations. So I'm taking like these standards so as if anyone would like to start, so these could be the starting steps to have these standards, and then they should have a knowledge in the IT development or programming or computer science. They can work on these aspects. So here the scope of this standard 235053 is define a framework for AI system using machine learning to represent knowledge, cover methods for the representation and exchange of the knowledge in AI system, addresses interoperability of knowledge across different AI and machine learning systems, include consideration for integrating knowledge-based approaches with data-driven AI. So, what is the objective? Standardization, standardized knowledge representation for AI, then enhance interoperability, support AI system development, integrate different AI functions, promote consistency in the AI practices. So next standard is also IEC 23894, information technology, guidance on risk management. So here this standard also we will try to see what it covers, like framework general, leadership and commitment, design of AI system, implementation, evaluation, improvement. Then risk management processes like a communication and consultation. Then risk assessment, general risk identification, risk analysis and risk evaluation, risk treatment or management, then selection of risk treatment options, and so and so. So here provide guidance for risk management in artificial intelligence, cover identification, identifying, assessing, and mitigating risk associated with AI systems, addresses risk throughout the AI lifecycle from development to deployment and use, include ethical, legal, and societal aspect of the AI-related risks. Then, purpose and objective, establish AI risk management framework, identify and mitigate AI risks, support safe AI development, incorporate ethical and legal consideration, promote responsible AI use. Next, artificial intelligence overview of the trustworthiness in artificial intelligence. This standard, like if I try to see the same way, here stakeholders, recognition of high level concerns, vulnerability, threats, and challenges of AI, then mitigation measures, similarly, controllability, strategies for reducing biasness, and then testing and evaluation and use and applicability. So the purpose what I'm trying to introduce, because many of you would be the beginners or the new learners, because I'm not expecting a MIT expert would be attending this webinar. So I'm trying to update you like these are the standards, and these standards are useful for the people who would be basically making use of basically this webinar. So provide guidance on the assessment of trustworthiness in artificial intelligence system, cover trust related factors including transparency, explainability, robustness, and accountability. Explore methods for evaluating and improving trust in AI system across different sectors. Consider ethical and societal impacts in assessing AI trustworthiness. So I just see people are raising hands for the question. Please keep writing your questions in Q&A window, and there will be a break in between where we will be having interaction question answer session where we will ask participant to raise their question and we will discuss. I will try to answer it in the live session. So please keep adding your questions in Q&A session so as we can take those questions and answer, as there would be one break in between. And then there would be also one question answer session at the end of the session. So here ICTR 24028 define trustworthiness criteria for AI, guide evaluation of AI trust, enhance AI system transparency, promote ethical AI practices, support AI development and deployment. So another one artificial intelligence use cases. This is like a good reference if we wish to see what has been developed in the past. So this is ISO IEC TR 24030. If you see this, there are like various user cases are there. There are 4 slides. Like use cases summaries: agriculture side, digital marketing side, education side, energy side, then fintech side. We go next slide. There are also various cases like healthcare, legal, logistics, then manufacturing. So various cases are there, and these cases are available in these standards we wish to use as a reference. Then this is a provide a collection of use cases for artificial intelligence across various domains, illustrate practical application of AI to demonstrate its capability and potential benefits, cover diverse industries including healthcare, finance, manufacturing, and more, offer insight into AI implementation challenges and best practices. Here, purpose and objective: showcase real world AI applications, then provide guidance for AI implementation, demonstrate AI capabilities and benefits, address AI challenges, support AI adaptation across sectors. So here it means for our people as well within Velosi, ISO IECTR 24030 is a good reference to look at what work has been done in past. Then there is ANSI standard, guideline for developing trustworthiness in artificial intelligence systems. So this also got the same kind of like information. For example, if you see that ISO and ANSI standard, there is a collaboration, and these standards talk to each other, and there are many commonalities between ISO and ANSI standards. So this standard also describes principle of ensuring trustworthiness in artificial intelligence systems, provide a framework for evaluating how AI adhere to trustworthiness principles, include guidelines for transparent reporting to stakeholders, then covers aspects of AI that ensure reliability, safety, fairness, privacy, and accountability. Aims to help organize build AI systems that meet ethical, legal, and societal expectations. Supports consistency in assessing and communicating the trustworthiness of AI solution across industries. So, purpose and objective of this standard: establish trustworthiness principle for AI, guide transparent AI reporting, ensure consistency in AI assessments, support ethical and responsible AI developments, facilitate stakeholder confidence. Then, the last but not least, definition and characteristic of artificial intelligence. So, this is the standard. So, Consumer Technology Association NCCTA standard 2089. So, the aspects are there, and then the scope of this standard is to outline definition and characteristic of artificial intelligence, to provide a clear framework for understanding AI technologies and their applications. It is applicable across various industries and sectors that utilize AI system, ensuring a consistent terminology and references point for stakeholders involved in the development, deployment, and evaluation of AI technologies. Provide clear definition of key AI terms to promote uniformity in communicating among stakeholders, outline the characteristics and classification of AI technologies, detailing their capabilities and functionalities. Encourage the ethical development of AI by offering guidelines that addresses potential risks, societal implications. Enhance collaboration among industry stakeholders with a common reference point for dialogue and understanding. Support policymakers and regulators by offering structured insight into AI technologies for effective regulation and oversight. Now, like knowing the standards, now I'm coming to the basic subject, the artificial intelligence for asset integrity management system. Let's say for the oil and gas sector, for industrial sector, for power sector, industry, energy sector, or any industrial or mining sector. So, what is first of all asset integrity management? So, asset integrity management is a systematic approach to ensuring that physical assets in industries and in the energy sector are maintained in a safe and operational condition. AIM help organizations improve the safety, reliability, efficiency, and probability of their assets. In recent years, artificial intelligence revolutionizing basically AIM providing new ways to collect, analyze, process data as well as make decisions. Now, as in integrity management and artificial intelligence, there is the merger between asset integrity management and artificial intelligence has completely changed, not completely, has made major changes, I would say. the way organizations manage and maintain their physical assets. This technological combination is built on data from multiple sources, including cutting edge sensors, historical records, and advanced basically imaging technologies. Let's see, like analyze image of equipment to detect damage. One aspect, like this technology allows organization to identify and assess potential damage to critical assets quickly, accurately, and non-intrusively. Analysis process is what? Capture data, upload and organize data, then find and mark damage, categorize the damage, and evaluate and repeat. So it means that image capture first, identification of the anomaly, and compare with the previous pattern, and then decide. The benefit, it can bring accuracy, response time would be better, and it can prevent like a major damages because you can review the condition of the pipe or asset beforehand, and then right decision can be made. In oil industry, all analyzer and AI analyzes images of a pipeline to detect incipient corrosion, allowing intervention before structural integrity is compromised. Because if the picture is coming, you can make the right decision. Then predictive maintenance, for example, predictive maintenance, there are vibration wise, oil testing side. So there are sensors to bring the data, they analyze, then machine make a comparison whether there is an anomaly or there is no anomaly based on the condition of monitoring, then applicable preventive or predictive maintenance is done. So benefit, it could be cost reduction, increased availability, and it can we can better utilize our resources for the high risk or the areas where you need attention. In power generation plant, AI can constantly monitor the performance of turbine and generators, anticipating unscheduled shutdown and optimizing the production. This is one of the example. Now, optimize maintenance planning. So we can optimize logarithms. Then we can also basically allocate resources as per the workload, which is analyzed based on the data available in the CMMS system. So it means that if effective use of uh, basically CMS system with the right and accurate data and true data. So these aspects can be managed by adding AI feature in the CMS system functionality and use. This will help in reduction of the cost and or downtime. It can also increase the operational reliability in a better way, and we can also increase the productivity. Practical example, AI improve wind farm maintenance for safety and efficiency by factoring in the weather. Then in manufacturing, AI schedule maintenance to reduce interruptions and boost productivity and efficiency. So aspects are there where like availability of better data and then analysis of that data and then decision making aspects can be brought by the AI factors. Next, remote monitoring and control. Like nowadays, IoTs means input and output like transmitters. AI works with the Internet of Things, which called IoT. Internet of Things also they call IoT to enable remote asset monitoring and control. Internet of Things, IoT, not IO like input and output transmitters, but it's the Internet of Things. Sorry for that. And control this particularly valuable in industries like oil and gas, where assets may be located in remote or hazardous environment. Real-time decision support, AI provide real-time data analysis and decision support, allowing operator to respond to emerging issues swiftly and effectively. So this is the like we have make some correlation between AI and the aims, like day-to-day functions what we are doing. So benefit point of view, so what we can forecasting and preventing failures, it can help optimizing inventory management for the warehouse based on the consumption ratio of the spares in the warehouse and to make sure they're always available and we have optimum number of the spares or the spare parts in the system. Then enhance equipment reliability. See, if we have a some trend analysis, we know identification of bad actors, and then focus is given on those bad actors, and reliability of the system is improved by minimizing the downtime or failures or unexpected failures. So, in a way, AI helps to improve the reliability of the equipment. Then increasing productivity, if reliability would be improved, if availability of the plant would be improved, then productivity will increase anyway. So by applying uh, condition-based maintenance activities to our own time, like if we can do maintenance of the equipment or preventive maintenance of the equipment before it fails, so it means it will reduce the cost which may occur due to the failure of the equipment. So this is another benefit which is added by the AI technique. So the future of AI in AIMS. So what we see that more autonomous maintenance, we may have a more advanced analytical analysis, then we may also have a more with the help of AI, IoTs, real-time computing of the information, then greater integration between various segment of the AIMS area, like greater integration of operational data for inspection, for maintenance, optimization, and so and so. So seamless integration with other emerging technologies like blockchain for transport supply chain management could also be covered in a to improve the more role of AI in the AIMS system. So now, if we try to go into our VAIL-Plant, is a software system, is asset integrity management system. It is a modular based system which covers like pressurized equipment management system, pipeline integrity management system, onshore, offshore, then electrical instrumentation, rotary management system, PSVs management system, structural integrity management system, lifting equipment management system, well integrity management system, or like civil integrity management system, CP system, and we also have the CMS, APMS, ISMS. So all these systems which are built for the like as a part of the one of the subset of AI where all the base data, their historical trends available, risk assessment tools available, then decision making trees available. So so we have made the system. This system is being used by many users in the globe, and like we also made the voice assistant Sarah. So if we can show the next, I think the video would be there. Just a minute. Let me go next stage. And so this is the video which like how the software is working. Some idea it will give you. So I'm just running the video. Please stay with me, please. Somebody is not coming.
Welcome to VAIL-Plant. Hello, I am Sarah. How can I help you today?
Sarah, can you open the PIMS module?
Sure, here it is.
Can you generate an inspection schedule for the main pipeline?
Task executed successfully.
Please show me the risk matrix of the IRMS.
Task executed successfully.
Right. So now we try to show you various features in the artificial intelligence. Before we go, Saab, should we have a question answer session? No, because we are in the middle of the presentation now, almost.
Hello.
But the question, how we help to prevent from major accidents? Yes, Mr. Yaqub Gol, if you can speak. Yes.
Yes, I am. Yes, in the oil and gas industry, there is always a major accident like explosion, fire, jet fire. All these are related to the integrity of the facility. Is there any possibility that AI can prevent from major accident?
Yes, sir. Mr. Yaqub, one thing we have to understand, as I explained at the beginning, AI, artificial intelligence, is same like human intelligence, right? So now all our assets are being operated by human beings, right? And our role is there to prevent the incident and to operate the plant safely. The question is how a computer or a machine can help that. Yes, it does help, For example, you have a DCS system, you have a CMS system like SAP, Maximo, or VAIL-Plant, and you got inspection management system, right? So if data is gathered and if condition monitoring of the facilities is being done properly, if preventive maintenance is being done on timely manner, and if in DCS, when alarms are coming, those are being attended by the operators and they're taking actions. So in a way, the DCS is also part of artificial intelligence. So now if the alarms are being attended by the operators and they're taking timely action. Secondly, if the condition of the equipment is being monitored by the condition monitoring and preventive maintenance is being done or functional testing is being done in timely manner. And similarly, if the due inspection activities are being done, data is being analyzed and due corrective action is being done. So in this way, AI helps to prevent accidents. But it is not like it will like a thing and then action would be done, but it will help you to execute the actions which are defined either by leadership or by computer. Okay, sir.
Thank you.
Thank you, sir. Next question.
It is on your screen from Mr. Obiakor. We have allowed him to speak. Kindly ask your question. Mr.
Obekar Samuel, I can read the question. Can AI technology remove the interface of human being in the oil and gas space when it comes to engineering management? No. AI has not gone to that extreme or that excellence level where the role of human being could be eliminated. It is like a same imagining like if the vehicles would be driven on the road without drivers and the AI features would be sensors would be built into the vehicles and they can run on the road without driver. It's still distance. Yes, even though there are trains which are running on the track without driver, but vehicle may not be able to run on the roads without taking safety risk. So same is the case here. So the AI features are there to optimize the activity to manage the asset in a proper way. However, it is not reached to that level where we can like say that without human being, AI would be able to run the operation of oil and gas in a perfect way. Is AI integrated in asset life cycle extension? See, when we have the computational calculations, when we have inspection history data, and then accruing rate is calculated or MTBF is calculated based on the failure trend, so it can help to extend the life of an asset. This is the question coming from Mr. Yusuf. I hope I have answered the question. So now I go back to my presentation again. Okay. So now, what are the features available in VAIL-Plant that I'm trying to go through? For example, there are various features which are available in VAIL-Plant. I will also go through like what is VAIL-Plant. It is a modular approach. But here, what we have, analyze images of equipment and detect damage. That is the first feature which is available in the system. The predictive maintenance can be done or organized by the VAIL-Plant. Then asset risk analysis is being done, optimized maintenance planning, remote monitoring and control could be done through with the help of VAIL-Plant, corrosion and fatigue monitoring, inspection, automation and analysis, work order optimization, compliance and reporting automation, then incident analysis and root cause analysis, health, safety, and environmental enhancement. So this is the first example. Here, I analyze equipment image to detect damage in asset for identifying the dent and crack that will help to you to prevent major failure and reduce downtime. This is the first action. It is like how the VAIL-Plant or artificial intelligence can help you to reduce the accident or incident at the facility. Second one, predictive maintenance. I analyze real-time data from sensor and historical data, and based on the past patterns, I predict when maintenance is needed. My proactive approach helps prevent issues and reduce costs, which increase the asset life. Next is a asset risk analysis. So I use machine learning and data analytics to analyze asset current and future risk and help in prioritizing for inspection based on the high risk assets. Optimize maintenance planning. So I optimize maintenance planning by creating cost-effective schedules based on maintenance cost and asset importance. This ensures that critical spare parts are available while minimizing excess inventory costs. Next, remote monitoring and control. So I enable remote monitoring and control by this, like Sarah is telling. Sarah is the basically voice assistant of the VAIL-Plant software. I does not mean it's a Sarah. Okay. I enable remote monitoring and control by integrating with IoTs, like IoTs mean Internet of the basically things, to provide real-time data, analysis, and decision support, helping operators respond quickly to the issues. Then corrosion and fatigue monitoring. So I assist in to monitor corrosion and fatigue, detecting potential issues early by analyzing engineering data, historical data, and real-time data from sensor based on international standards. So here I utilize computer vision to automate inspection processes, analyzing data from various sources to identify anomalies. This streamline inspections, ensuring assets are assessed efficiently and accurately. Then work order optimization. So I apply optimization algorithms to optimize work orders, prioritization tasks based on urgency and resource availability. This helps to organize, allocate resources effectively, and improve operational efficiency. Then compliance and reporting automation. So this is one of the report. So I use natural language processing to automate compliance and reporting processes, ensuring that all necessary regulations are met. By streamlining documentation, organization can be maintained compliance with the minimum efforts. Then incident analysis and root cause analysis. So I use data analytics to analyze incident and identify root cause by examining data from past event. I help organizations implement corrective actions and preventive future occurrences. Then health, safety, and environmental enhancement. So we do take care of the consequences. Basically, I assist in corrosion monitoring, controlling to environmental sustainability to maintain these matters. Now, why is activated AI with Sarah in VAIL-Plant, which I just showed the video. Sarah, powered by AI, allows user to interact with VAIL-Plant using natural language processing (NLP), making the platform more user-friendly. A user can use voice command to retrieve reports, start inspections, and check asset status hands-free. AI simplifies interaction, increase user efficiency, and access to critical data. Introducing Sarah like a BOT AI in VAIL-Plant is reduced like a manual clicks, faster task execution, faster analysis, improved accuracy, and available 24/7. Here, Sarah is coming from systematic, accurate, reliable, and accessible. Sarah, systematic, accurate, reliable, and accessible. Then simplify the workflow. Number two, provide real-time insights, hand-free navigation, smart assistant to boost efficiency, manage tasks with minimum human intervention, and retrieve data on voice command. This is Sarah's feature in VAIL-Plant. Then, like VAIL-Plant AIMS AI modular, basically digital twin factor, like a digital replica of physical assets, predictive maintenance, real-time performance insights, then optimization of the operations, extended asset lifespan, then promote sustainability and reliability. So if modules, the VAIL-Plant Asset Integrity Management Software modules, I'm just trying to go through that. So asset integrity management system outline the ability of an asset to perform its required function effectively and efficiently whilst protecting health, safety, and environment, and means of ensuring that the people, systems, processes, and resources that deliver integrity are in place, in use, and will perform when required over the whole life cycle of the asset. So these are the like modules I explained earlier also. This is the welcome to VAIL-Plant, the integrity management system. I'm Sarah, your person. This is like how it comes in. So it is certified product by third party, CETA in accordance with API 580, as may be 31.8S and API 1160. Then IEC, the software is developed in accordance with IEC 61508, software development and process certification. Then also it is certified by SAP with its integration. A cost saving in-house developed like a fully certified solution to manage the efficiency of the physical asset on a single platform. This is what we claim. So modular approach, hierarchy recording, voice recognition, dashboard overview, asset management, condition monitoring, risk assessment, defect screening, FMECA analysis, inspection plan and scheduling, inspection and maintenance history. All this is part of the system. Then root cause analysis can be done, data verification can be done, integrity operating windows are part of the system, KPI management, work order management, failure, replacement, maintenance, and anomalies records, estimated corrosion rates, integration and interfaces, standard customization reports, cost, time, and resources estimation. So data reliability and integrate, feature-wise, data reliability and integration and inspection and maintenance aspects. So overall management of dashboards, bulk loading, data importing, exporting templates, role-based security, ERP integration, ArcGIS integration, inspection data loggers, third-party RBI softwares integration, then active directory, workflow configuration for inspections, customizable inspection and maintenance business processes, inspection management with identified user roles, then notification management, work order management. Reporting, and the custom queries are there, document interface is there. Similarly, this is the first module, what called Asset Performance System, APMS. So this module interact with various modules of VAIL-Plant, where we can look at the RLA, anomalies, MTBF data, bad actors. We can also integrate data with PI historian, census data, condition monitoring data, and work order status and KPIs. Then CMS system, where we have this like a Maximo or SAP. We also have a work order execution system, and if a cost-effective system is required. So we have one stage, modular approach, complete integrated management solution, including all asset-wise modules plus CMS, ISMS management system. Then first one module pressurized equipment management system, which is covering pressure vessels, heat exchanger tanks, and piping systems. So it is a semi-quantitative, quantitative RBI is there, RLA, metal loss, corrosion rates, then inspection planning, inspection history recording, trends in terms of anomalies, defects, leaks, and replacements. SIMS is a structural integrity management system which cover that dashboard, risk assessment, structural component, supply zone, topside, underwater, and then inspection plans. It covers all. Then there's a PIMS onshore with the pipeline onshore. It covers pipeline data, section, profile, pipeline assessment, defect assessment, then code check as per 31G or Shell and DNV standards, ILI results, direct assessment results, IOWs, anomalies measurement, condition assessment, free span, and on bottom stability and inspection planning. So EIRMS module facilitate reliability center maintenance approach for the electrical, mechanical, and instrumentation equipment. It covers the FMECA, PMR, job plans, MTBF, MTTR data, risk assessment, and RCA facilitation. Then PSV's MS also covered FMECA approach, PMR, job plan, MTBF, MTTR, risk assessment, and RCA data. Similarly, for the lifting equipment, so it covers the various checklists as per for the applicable for the lifting equipments, and then FMECA, PMR, job plans, risk assessment, and RCA information. SIMS also covers FMECA approach, historical data management, PMR, checklist, and risk assessment, and RCA approach. Same for the CPMS, we have the normal engineering data, FMECA, PMR, job plan, then MTBF, MTTR, risk assessment, and testing and monitoring records. Well integrity management in accordance with ISO 16530, it carries like a database, hierarchy, FMECA, PMR, job plans, then MTBF, MTTR data, risk assessment, and RCA feature. Hull integrity management, it covers like a complete ship, how it is being built and managed, risk assessment, then inspection execution and inspection planning. ISMS is basically inspection management system, which basically works this in the interface of the CMS system. Then patrol station risk assessment, which is built on HSG 146 PSRA, interactive checklist, handling flammable fluids, inspection planning, inspection history recording, detailed recommendation for each equipment. Then allows our system allows integration with the various outside softwares as well, including Oracle, SAP, Maximo, or data loggers, then API core, EAM or Info EAM. So what we deliver to the client is number one, development of software requirement specifications, then installation of standard VAIL-Plant software, customization and configuration, population of client data in software, deployment in client test environment and UAT, then system training and software documentation, go live, support and maintenance after installation. So data loading, client provide data to Velosi in electronic editable format. Velosi import the data into VAIL-Plant. Velosi perform quality checks to ensure the integrity. Velosi extract all engineering, operating and design and historical data population in VAIL-Plant. This is the data loading. Then training, Velosi follows train the trainer module. Two experienced trainers are allocated to transfer the domain knowledge to trainees. We provide training kit, then hands-on training and certificates for the training as well for the people who will be completing the training courses in VAIL-Plant. Then implementation side, like what we cover, standard system installation, system customization, system integration, system deployment, then user acceptance testing, go live, support and maintenance. Support loading data into VAIL-Plant afterwards if the client would be uploading information itself. Then we have 1 week advanced training performed for the number of users, then provision of software documentation is a part of the training as well. So now there's a last step, we're covering only one aspect, case study for successful implementation of AIMS and APMS system. So I will be showing only the AIMS system as a last step of our presentation. The objective of implementation of asset integrity and performance management are as follows, like to evaluate the following in asset integrity management perspective: offshore structural platform, pressurized equipment and piping system, subsea pipelines, pressure safety valve, electrical instrumentation and rotating machinery. So these systems were covered. Collection and review of the engineering and operating inspection and maintenance records, RPA assessment of structural member, joint component equipment, piping system and the pipeline with AIMS within AIMS system. Then FMECA for the electrical instrumentation and rotary system and PSVs, then preparation of inspection and maintenance plans, integration with ERP system, visualization of the summary, dashboard and status, and then store multimedia files such as pictures, videos and drawings in the VAIL-Plant system as well. So these were the number of equipment, like 5 pipelines, then 6 structural platforms, piping equipment 79, piping 183, offshore structural platform 3 member joints, the number of equipment 2,353, and joints were 735. Electrical instrumentation and rotating equipment 585, PSVs 786. It's just a sample data. Then process equipment piping system, VAIL-Plant PIMS module, stay here. So what we did, that identification of asset for RBI study, collection and review of engineering data, inspection history review, identification of potential damage mechanisms, preparation of Korean loops drawings, API 580 RBI assessment on selected assets, RBI analysis results, overall risk metrics, critical equipment and piping, development of inspection plan, guidelines and inspection sketches, VAIL-Plant pressurized equipment management system module implementation. So these are the number of equipment which I covered earlier. Further breakdown is there, where vessel 53, drum 08, storage tank 09, and peak launcher receiver 09. So information what was collected, PNIDs, PFDs, equipment data sheet and GA drawing, heat and material balance sheet, line designation table, line list, piping specification, equipment and piping inspection history. So like the preparation of the Korean loop, which were prepared for various systems or subsystem of the process. Then identification of potential damage mechanism, which were identified as erosion corrosion, CO2 corrosion, corrosion under insulation, atmospheric corrosion, microbiologically induced corrosion, MIC, soil corrosion, under deposit corrosion. And basically here the count of equipment component inspected by thickness, the inspection record is basically updated. So total number of equipments, inspection by thickness, no inspection by thickness done. Then piping wise also same thing. So then overall risk matrix distribution, like the equipments were mostly divided into like this area, high risk 9, medium 138 and low 198, total 345 components. The risk identification is one of the most important benefit of AI, which VAIL-Plant perform efficiently. Then development of PIRs mean inspection plans, like type of equipment, either pipe or any other equipment, then type of inspection, either on stream, off stream, then inspection interval, either 3 years, 6 years, 9 years, or it could be different also. Intrusive, non-intrusive inspection, either internal or external inspection. Material of construction, either CS, SS, or cladded. Service type, either suite, hydrocarbon, solar hydrocarbon, or utilities. Insulation status, either insulated or non-insulated. Equipment position, either vertical or horizontal. Then the inspection drawing is made. Then VAIL-Plant module, it contains a comprehensive database for piping and pressurized equipment. It covers the complete risk assessment process and facilitate inspection planning to predict the inspection asset remaining live and next inspection date. This module is based on API 580.2016. So, dashboard for overall report on the vital integrity metrics, engineering data, and specific engineering data, then historical records for inspection, failures, and replacement, along with root cause analysis for failures, condition monitoring, including thermal cycling, PMI, fluid analysis, CP system, ERP, crane coupons, flow-induced vibrations, RBI assessment, inspection planning, inspection results and code compliance checks, and KPI calculator. So this is the basically dashboard on the PIMS module, where we see the remnant life, risk distribution, and inspection and PM activities, corrosion rates, leaks, defects, and replacements. And this can be configured based on the client requirements as well. So here, like how we have the various, like a VAIL-Plant displays a well-organized equipment hierarchy, if you can see here, and along with the engineering data. So here we can attach or refer all the documents for the equipment and piping system, and this is basically hyperlinked with the documentum system of the company or operator. Documents on voice command helping you to use the system efficiently. Then here is the basically RBI process. Sarah is showing the allocate damage mechanism field to assist you in making timely decision. These are historical data. Then it shows like a various graph and trends, like pinpointing asset with alarming metric value help in timely decision making and avoiding major losses. This is the calculation of the POF, COF, calculation of the risk, calculation of the condition assessment. On your voice command, I have opened the RBI results. Here, the calculation the employed for calculating the next inspection date for VAIL-Plant teams are enumerated below. Calculation of the metal loss, calculation of remnant life, calculation of the internal planning effector, calculation inspection interval, calculation next inspection date. So by automating inspection process and pre-identification of next inspection date, VAIL-Plant assists you in making informed decision. So this is the like next inspection, what inspection should be done, like visual inspection, UT gauging, UT scanning, or RT. So then it helps you calculate corrosion rate, metal loss, remnant life. Then this is basically the reporting feature of the VAIL-Plant. Through a view report feature, the desired report can be accessed, downloaded, and printed. The VAIL-Plant inspection scheduling management system, which is another module of the VAIL-Plant, which covers basically ISMS module coordinate with other VAIL-Plant module to facilitate their inspection planning and recording. With ISMS, inspection schedule management system, the operator can schedule and execute inspection scheduled generated while documenting the inspection to create work orders. So these are the like ISMS, where the how we execute various inspection activities. I can assist you scheduling new inspection using ISMS module. So the features in the ISMS capable to manage inspection activities for all type of assets, allow user to plan, schedule, and execute PIRs, user-friendly configuration of workflow and role involved, allow monitoring process of the PIR plan, allows review and approve vendor remarks and comments, and preserve history of these remarks. Bulk data importing from Excel workspace template for the fast data feeding, allow users to create work scopes, work packages for execution of PIR on tag or set of the tags. Role-based access, audit trails, data security and integrity, color coding to have a one-look summary of the status of the inspections, recording of a wide array of inspection techniques. So one is ERP, like we have enterprise resource planning model, interface point of view. So here we can integrate with SAP, Oracle Maximo, or our VAIL-Plant CMS module as well. Then another like common module which I'm just showing, APMS, like Asset Performance Management System. So this system basically, the VAIL-Plant APMS module is an operator single window specifically designed to equip oil and gas organization to monitor the overall status of the system integrity parameters such as remnant life, inspection activities, leaks, features, then risk ranking, MTBF, work order and bad actors, corrosion rates, replacement via the dashboard. It allows the operator to perform extensive filtering to review the desired output in the form of graphs and reporting of the data analysis. So it combined with RCM, RBI, pipeline, and structures. So this is one of the common dashboard of the basically APMS. The using VAIL-Plant system, the upstream data of a client client is converted into visual form of the analysis. It serves as a report card of existing asset in the system. The various parameter can be drilled down further at different level to the specific module. So the feature-wise, user can view the complete integrity parameter of VAIL-Plant, different modules under one screen, single dashboard for RBI, RCM, pipeline, structure, and process information historian studies. The view total tag count, total number of completed RBI studies, and total number of completed FMECA studies on the screen. View overall status of VAIL-Plant modules individually and together. Filter out the graphs with respect to the area and modules on the navigation tree. User-defined graphical chart and data. View the relevant detail of the metric by clicking any graph or reported figure. Redirect the module to view the particular metric details, basically. And it concludes my presentation. Now, before we call the day, we will have another question answer session. And if the participants have raised any questions, we can answer. And you can also participate by asking your question.
Hello.
Yes, please.
Yeah, Akshat Agarwal here. I am in ADNOC Offshore, and I am dealing with materials and corrosion side. So my question about risk assessment, first question is, you mentioned about the performance management, which is linked with the RBI pipeline, structural integrity, and all different interfaces. So how the performance of the system is assessed based on some published worldwide data or
there are two aspects. Like first of all, if you are familiar with API 571 and API 581, there are empirical equation and modules are available where we can do calculation of various corrosion rate under various process conditions.
No, we are not. I'm not talking about corrosion rate. Corrosion rate does not consider the localized corrosion and many other phenomenon. It just consider the general corrosion rate, which is not the high risk anyways. So I'm not talking about corrosion rate as such, but I'm talking about different kind of failures, corrosion failures other than the general corrosion, localized corrosion, erosion, fatigue, and other things. So the general risk assessment, is there any intelligence, worldwide intelligence built into the system?
See, if I go back to history, like one thing where the intelligence will come, that would be coming from your assets, right? First of all, your own assets. If the historical data would be built, then if you have some trend available from certain services and similar service pipeline, similar condition and material, then it can be extrapolated to identify, okay, if you have a problem with this kind of line, then you can have a problem with similar other line. Number one. Number two,
many phenomena are not identified, like microbial corrosion, or there are gray areas, you know.
No. Microbiological area is very much understandable. Like if the biocide is being done, not being done, or if sampling was done, SRBs were detected, not detected. So at least, like it is one thing is there. It is the artificial intelligence, right? And artificial intelligence and human intelligence work side by side. If human can answer, artificial intelligence can answer. Like artificial intelligence is behind human being, not in a head of human being. So what is
I
being
mean,
stated
in a
here?
particular, my question again, to be very specific, in a particular application, suppose subsea pipeline application or something like, if I want to know what is the chances of microbial corrosion in general as per the worldwide published data, is it
See,
possible, or we
see,
can get this
see.
answer, of course, within
When we say published data, right? So the published data, like ORIDA is there, for example, where the upstream or operators data is available, right? For certain failure rate data is there, like what are their like failure modes, and what are their maintainable items, and what were their causes. So this kind of data is available. However, like we see that in ADNOC, there are various tenders are also there. We are also doing on various jobs where, for example, if a line is unpickable, right? And if you don't wish to do any inspection also because it's not pickable and access is also restricted. So what to do? So in that scenario, we
No,
have
no,
to
I mean
correlate.
performance. I'm again, I am focused about the performance management. So if you are talking about picking performance, how can you elaborate more on the performance management, how it is done in your software?
See here, what system provide, first of all, the population or the gathering of the information in accordance with API 1160, which is the oil pipeline integrity management system. And then you have to arrange the information as per ports. There is a international like a body who the how pipeline information could be correlated. Then it goes to one pipeline is a kilometer by kilometer. So how the engineering, operating, historical data is placed. Then how the trend of that particular pipeline could be made, like in which way the pipeline is trending based on the previous history of that pipeline. If you don't have that history, then you have to correlate that line with another pipeline where you have an history, right? Without these
And
two
based on all this,
correlations,
sorry to interrupt, based on
uh,
all this, how you categorize whether performance is good or percentage wise, or how the output will be given in what form?
output wise, it will you have a trend. For example, even in front of my laptop, now I could show you. See, you have a various trends based on anomalies, based on the leaks, based on the failures or the metal losses or anomalies. So in that way, you try to establish the trend, whether you are in the positive regime or you are in the negative regime. And based on that, you define whether the performance of your asset integrity management system or your inspection regime or the operators or the inhibition injections and so and so is effective or not effective. It works
And
that
you
way.
also, is there Bayesian or Weibull distribution and such capabilities are there in the software?
Those are there. Those are basic probabilistic calculations. That is a part of the risk assessment approach. Yes, it is there. So if you require, then we can have another presentation and discussion with you where we can demonstrate the system to ADNOC offshore as you need. No problem. We are just 10 minutes away from you.
Okay.
Walkwise. You're in the trade center and we are on the Hamdan Street. Okay, sir.
Okay.
Thank you very much for your question.
Can you hear me?
Yes.
Thank you very much for this good opportunity. I just would like to know, can AI and can this your contribution assist us to detect, categorize, quantify the emissions from the oil and gas plants?
Mr. Faisal, right?
Yes, Muhammad Faisal is here.
Okay, you're saying, can we get assistance from AI to detect, categorize, and quantify the emission from oil and gas plants? When you say emissions, right? Now here,
Yes,
there are two, it goes to the environmental side, right? If I'm right,
yes,
environmental side. So main emissions are two. One is from the flare, heater chimneys, boiler chimneys, and the vents, right? Which goes to the air, right? Now,
yes,
second one is your water base, which are like a drainage system or oily water system, or all drains goes to your ponds or wastewater treatment system, and then sludge or the water is being wasted. And the third could be your seawater if you're taking for the cooling and throwing back. Right? Now, all these parts, basically AI, if it is linked with your, for example, if you have some analyzer or monitoring tools linked with the all flare and chimneys, right? Then it could be summed up. and then you can report like what are the emissions and SOx, NOx, and what the quantity point of view or the tons per day that can be calculated. Yes, similarly, if the sludges and those parts which are being calculated by the system, that features are available, but this is not part of this system. We cover it under HSC performance monitoring. That a separate system is
Fine.
available. It's doable, sir. Not under
Fine,
VAIL-Plant.
fine,
Right.
fine. Thank you very much. Thank you.
Thank you. Thank you. Okay, sir. Thank you very much for the day, and we look forward to meeting you in the next webinar.